My name's Robert Stratton. I'm VP of Analytics at MarketShare. And MarketShare is a marketing analytics and software company. We work with a lot of big advertisers, so a lot of the stuff that we do is around looking at the marketing effectiveness of different, basically different marketing instruments that the clients are using. Our clients are spending a lot of money on the different things they're doing, so for us, innovation is about finding different ways that we can help them to either measure more accurately or to optimize the media and the marketing instruments that they're using. So some of the things that we've been innovating recently from the statistical point of view are structured equation modeling. So that's different ways of looking at how marketing is working over time. Also hierarchical Bayesian methods, so that's looking at different ways of modeling customer behavior. And then latent instrumental variables, which is a way of dealing with heterogeneity. So I guess these are all quite technical statistical things, but these are some of the things that we've been working on. All of the things we do need to feed into essentially a digital marketing ecosystem, so that means they need to be running in real time and often running live on client systems. So just to give you an idea of the kind of data that we're dealing with, and I'm not sure if you can see all of those small text around the edge. But essentially we've got a mixture of different types of inputs that we're putting into these models. Some of them are things that the client controls, so for example advertising, promotions, events, etc. Some of them are things that are outside of the client's control, so that could be, for example, the climate, the economy, competitor actions. So all of this data feeds into the models that we have, and really what we're trying to do is to say what are the different impacts that these different drivers have on customer behavior. So that's customer behavior either at a individual level or at a cookie level, and all of this data feeds into our system. So once we have the data, we have a system of equations that all links together, and it brings in different types of information. So on the left-hand side, we've got the core of the information that's coming in, and that's really where the big data, the event-level logs are feeding into the database. Those feed through, they're transformed in various ways, and they feed into the individual level model. Then from a time series point of view, we're feeding in a lot of other things, and those are things that change really over time rather than being individually addressable. So that could be, for example, a change in the weather might cause a change in customer behavior, a change in the economy might be good for one brand but bad for another. And then finally, we have a propensity model, and the propensity model is really there because in general, we find that somebody who may have shopped from your brand maybe 17 times in the last year is much more likely to buy again than somebody who's never bought from the brand before. So all of these things feed in together and create probability model, which is the core of our attribution process. So we're looking at how each of these things changes the probability that somebody will actually buy the product at the end. So in terms of the overall data process, there are four main stages. Data ingestion is where we're bringing in data and transforming it. There's quite a lot of work in the ETL and load. Model creation is where we're developing the models, and those models feed through into an attribution analysis. So that's looking at what are the different drivers and how do those different drivers impact the probability that a customer will buy. So that's really decomposing what are the effects in the model and interpreting them. Then finally, all of that feeds back through into the ad platform, and that's where the impacts of the different models are optimized and fed back into something that the client can do. So for example, spending more money on display, taking money out of search, etc. So there are two main points where we want to look at the data that's being processed. So the first one, in any particular client deployment, once we've loaded the data, we want to get into it and have a look and check that all of the data is essentially loaded properly. So there's a point at the top left where one of the data engineers will want to open up the database, have a look at the data, and check that everything's okay. Then the second main stage is, once the models are complete, the modeler wants to get in and have a look at the models, wants to look at the data that was used, and check that the attribution has come through in the way that they expect. So that's really the two main areas where we're looking into the data and getting into the data process. So what we found is that by using Alation, in general, we can get into that data and access it in a way which is much more accessible and user-friendly than the other methods that we have. So some of the other ways we have to get into the data include the command line, for example. And what we find that is by using Alation, we can get the data in a good format. We can pull down small sets of it and have a look at it in different ways, perhaps in Excel. And also you can access the underlying database structure, so we can get into what tables are in a particular schema, what fields are in those tables. And all of that is very helpful for the analyst at the time that they're doing the modeling. Also, we have clients we have users in lots of different locations, so from Bangalore to London to Los Angeles. And the features for collaboration that Alation offer mean that we can perhaps pick up a query, pass it to somebody else with a note, and that person can pick it up in a different time zone at a different place. So I guess it varies in terms of the productivity increase that we see depending on what the application is. But in general, we estimate that we save around 50% of the time just by using the Alation interface. Quick look at what our overall technology stack looks like. So I guess the main things to call out here that are most relevant are Hive, Hadoop, Alation, R, and H2O. So those are the main core of the process, and then the other things that we're seeing, the other things you can see here, kind of feed into the data stack at different points. So just to sum up, these are a couple of the things that we've learned from the years of being working with the big data. So I guess the first one is it's still important to look at the data. However automated the processes that you're using, you still want to get in and check. I guess everyone has their own horror stories of what may have happened during the processing that you want to make sure that everything's come through okay. The second one is that although the product is a big data product, it's we've got a lot of terabytes of data feeding into it. We also need to bring in things that are not big data. So small data makes a difference. Information about offline advertising, the economy, the climate, all of them can feed in and actually make a significant difference to what customers are doing. So bringing in all of the data, not just the big data, is also important. And then finally, what we find is that although in a lot of machine learning applications, correlation can be the only thing that you need to look at. So for example, in cross-device matching, you might only be interested in whether one thing is correlated with another. In the particular case that we have, we're interested in whether changing X changes an outcome in Y. So we're looking for a causal model, and for us, correlation is not sufficient to answer the questions. So that was just to summarize. Those are the three main things that we've found from doing this kind of work. Alation are at booth 258, and I think there's a booth crawl at 6 p.m. tonight. Also, you can find Altiscale at booth 242 and H2O at booth 734. That was all for today.